Hey everyone, I'm Brian Wood, Technical Communications and Outreach Manager at Wolfram. I'm here with Shadi Ashnai, Manager of Sound and Vision. Welcome, Shadi. How are you doing today?
Thanks, Brian. Doing fine.
Shadi's going to show me some of the latest video and image processing functionality in the Wolfram language. So give me kind of an overview here. What's the general direction of image and video processing in the Wolfram language right now?
Our major focus since last year has been video, of course. It's the newest feature we released in version 12.1. All experimental, as a lot of it is evolving as we speak. So most of the team has been focused from the import-export side of it to basic editing and being able to show some GUI that works in the notebook, as well as advanced analysis, which is we all believe is going to be the strength of having any video support in our Wolfram language. So that has been taking a lot of effort, a lot of resources from the team, but we've as well continued working on our image and audio capabilities, whether it's better support for file formats, looking back at existing functions, making adjustments or improvements, implementing suggestions, or even adding any utility functions or even bigger features like face analysis stuff that is really important and nice for us to have.
Yeah, well, and I know image and signal processing and audio processing and video processing, it's all sort of linked together, and it's been a pretty big area in general, I think, in industry. So it's pretty great for us to be implementing all that stuff
very much so
over the past few years. So, and you actually gave a talk about this last year as well. So why don't we just start with some of the stuff that's sort of new since last year?
Sure. Do you want me to share?
Yeah.
And maybe show some examples as well. So I think since last year when we spoke, I believe video was not released, but we were working on releasing video. Just to recall, video is a first-class citizen, an object in the system. It displays as a video GUI, a video player. We have our default as a thumbnail viewer, which is a small thumbnail of one of the frames of the video, opens up in an external video player. But we do have other GUIs, which are basically our working prototype for having an in-notebook player. This is a snippet of, this is basically the future that we are trying to work to have.
Right, so it's just built in right there in the notebook. You can navigate through it, turn the volume up and down, things like that.
Right. And this video has one track only, but we do support multi-track video, multi-track, multiple audio tracks, subtitle tracks, and so forth. And this GUI already is capable of either displaying or emitting the sound from different audio tracks or showing subtitles for different tracks.
So when you say it supports several tracks, those are sort of something that's built into whatever video you're importing that the system then recognizes. Okay, cool.
Exactly. For instance, if I get another example here. I
really like our video examples here too. They're a lot of fun.
Right. And for instance, this video has 3 audio tracks, 2 subtitle tracks. And with the GUI, let me get an older version. Just a GUI in the prototype build I'm using has a glitch on those. But if I can get my 12.1 running, I can show you how the GUI can switch between those. But the support doesn't end at the GUI display. It actually also all right, let me see if I can get one notebook here. Okay. So here it is, all our multi-track video object. I can start playing. I can switch to show any of the subtitles or even play any of the audio
The male
tracks.
adult has red underparts, but females and young birds have gray underparts.
I see. Okay.
And the support does not stop at just displaying or emitting the sound from different audio tracks. Even in processing and analysis, all of those tracks are coming together. You can, do analysis based on the bird sound from first audio track, or do speech recognition on the second audio track, and so forth.
Wow. Yeah. So everything is just ready to be analyzed.
Yeah.
Very cool.
Okay, so just to continue on that, on what got released in 12.1, let me reevaluate this one quickly. So the Caminandas example that we had was a one video track, one audio track. It's an MP4, and the codec is one of the most typical codecs, H.264 AAC. The support for very many formats and codecs has been one of the major efforts we put into our video project before 12.1. And there's been very little work on that after 12.1. It is solid. It supports, as you see, for, let's say, MP4, almost all codecs that are out there for MP4, and also other containers that we support. This is our video decoders, which means which formats we can consume. Same thing for video encoders, which basically tells us what formats or using what containers we can create video files. So that's the essence of it. 12.1 basically has video as first-class citizen, and we are complete as far as what types of videos we support.
All right. So what else do we have that's sort of up and coming in the new 12.2 then?
Okay, so very briefly, since I just have them up there, small things that got added in 12.1 as well, just to make sure it's not just the bare bones. Things like trimming a portion of a video, extracting some frames from a video, and then you can immediately feed them to functions that are supported or coming from our image processing suite, like image collage, or extracting the whole audio track from a video object and then performing audio was also a major piece. So accessing different parts of video was available. We have had some general processing and analysis. I guess my favorite is video time series of some measurement. In this case, I'm doing mean intensity frame by frame, looking at video frames, computing some property. It doesn't have to be mean intensity. Something that we are proud of is, these progress indicators that for video is kind of essential. We developed on that, and the whole system is going to use this progress indication framework. And then again, the whole system just comes together when you want to visualize or analyze further the data that was computed. Programmatic playback was also important and essential, specifically when in the future we do get to real-time analysis of video files. A very simple example, I can create a stream connected to a video file, and then if you recall, we used to have dynamic of edge detect of current image as one of our very basic examples. And now I have dynamic of edge detect of current frame from that video. And if I start playing, you can do whatever processing on that.
Yeah, so it's live processing the same way that a lot of our sort of camera image processing functions have been in the past already.
Exactly. So this is what got released in 12.1. You asked me what's coming next. One of the major things we spent some time on, and there is going to be more time spent on it post 12.2, is generation. A lot of people want to generate videos from their work, whatever it is. In this example, I have a geometry of a horse, and most of the times you interactively go around to see the 3D object. If you want to show this to somebody, just revolve through the 3D object. We are introducing something called video generator. And this goes through, and basically what I'm doing, I'm performing some geometric transformation, which is a rotation transform around the horse. I had this pre-computed so that we don't have to wait for it 30 seconds. But anyways, this is not taking a lot of time anyways. I'm creating a lot of frames. And once this is done, the video is generated, immediately we wrap the video object. It gets represented in the notebook as video object, and one can perform any analysis on it or just share it with anyone, as the file is there and it can be sent to anyone.
I see. So it's maybe kind of similar to like an animate or a list animate, except it's more video and not just a series of images.
It is going to be, this is the feature of our prototype build, nightly builds. But this is a file. This is an out of core file. It can potentially be hours of generated video, as opposed to animated list animate, which is all in core. You need to have all of the data for all of the frame in the notebook, which obviously gets infeasible if you have a very long series of images.
Right. Yeah. That out of core is key for any large video projects, for sure.
Of course. And that makes it possible for us to be able to consume or generate any kind of video at this point. Without that out of core support, we were limited to a few seconds of low resolution video files.
Right. So does that also help? I mean, does that speed up the process? Does that change how quickly you can create videos and the analysis, or?
Not necessarily, because you have to write if my video fit in my memory, it would be obviously faster to create everything in memory, just like list animate, and play with it that way. The import and export, the I/O process is going to be unnecessary if everything is in core. But once you have out of core, what it enables is the fact that you can have large amount of data sitting on the memory, and then you fetch as much as you need. However, we have put a lot of effort into making sure our I/O process is as fast as possible, and we are still looking at it and trying to make it more efficient whenever we find room for improvement.
Gotcha. Yeah, that makes sense. So there's always a little bit of a trade-off, but it's still optimized to the best of our language's ability. Cool.
Of course. Along the lines of generation, we also extend video stream in 12.2 in order to be able to capture video from screens, so your monitors or the webcam. Again, this is similar to dynamic of current image. Instead of creating dynamic images and discarding them, if you're capturing frames from the webcam, we're capturing them and putting them in a file. I won't demo this, but this is the kind of syntax that is going to happen. Just like I was able to do dynamic of current frame of the video that I was playing, I can basically dynamically see the frame that is coming from the screen or the webcam, and then record it into a file, and then at the end. One of the very useful use cases of this, for instance, built into our system, is if somebody is, say, presenting from a mathematical notebook, and then instantly they can record their notebook and record themselves, and basically have those recordings, those videos available on their site.
Cool. Yeah, that seems like it'd be really useful just for sort of live streams and things like that, where people are showing off their code. And
definitely,
I know we're big into the live coding thing at Wolfram, so very cool.
Yeah. What else? Some editing capabilities. The list is long. We really don't think this is going to be the essence and the value of Wolfram Language when it comes to video computations overall. But people need this day to day. Trim a part of the video, transcode from this format, this codec to another, combine the video track with audio track, sequentially join or split, or delete some unwanted parts, or reverse for some effects and so forth. So this is a subset of list of editing capabilities that we would like to eventually have implemented. This is the list that most probably is going to come into 12.2, plus minus some functions, I would say. Sure. And the way we refer to this is essential capability so that people can do other more advanced analysis and computation in our system. We don't necessarily think people are going to come to us to join two videos, to connect two videos. There are way too many software out there that can do that. But analyzing how many people came and went from, in total in my video is something that not every software is capable of doing.
Right. Yeah, and it's convenient if you just have those basic things built into the language so that you can lead up to the more advanced stuff, I imagine.
Of course, you don't want to leave the system in order to be able to, say, for instance, combine your already generated video with some audio that is sitting there to get something like that, right? So these are essential to have, but I don't think these are going to be the major strengths of our language anyways. We have looked at general processing and analysis. Video frame map from version 12.1 is staying. Video time series is becoming video map time series for those who have looked at 12.1 capabilities. So this one is able to get one video track, transform it given a function, say color negated or edge detect or image adjust, whatever image processing operation, frame by frame or multiple frames by multiple frames. For instance, blend five frames, 10 frames at a time to get some kind of a blend effect over time. And then audio track apply new function in 12.2 is going to be basically the same concept for audio tracks. One audio track sounds very low. We can just normalize that or amplify that. One audio track has some clicks. Just remove those and so forth. So these two are basically corrections or general processing for one track at a time. These are three very general functions, very big. So all three of those and the output, input, outputs, well, input always video. One outputs a video, one outputs a list, one outputs a time series, which is those results that you got back in the list with the timestamps. All three of those are very general in a sense that the function can take image from video track, audio chunks from audio track, and subtitle chunks from subtitle tracks. And it can consume data from any number of tracks that exist in the video. And the function arbitrarily processes all of those. Only in the first case, we require that the output is either an image that goes into a video track, or it's an image audio combination that goes into an image audio track. For the other two, it's really flexible, like the example I have here. With the bullfinch, this is going to basically get renamed to that video map list.
Gotcha.
Oh, right. I just had these pre-computed, so I may wait on these. And again, these are all getting faster as we speak. But I can run that function with a function called with a function like dominant colors to compute dominant colors of every frame. So this is the result of first 10 frames. I can do a tally of all colors detected in all the frames, do a word cloud to see what colors were more dominant overall in the whole video, and so forth. So anyways, these functions are going to be very general. These are the kinds of applications that they can enable in our system.
Yeah, it's really cool that you can sort of take not only the video and audio itself, but the underlying data and sort of do things with that, and especially the sort of visuals that I've seen so far, and some of these seems like they'd be really useful.
Yes. And the list of our specific analysis functions in 12.2 currently includes one that I categorize in that, which is video intervals. It is basically working with the result that comes back from video map list or video map time series. And then it looks at, it basically works with a criteria that says, does the analysis fit this criteria? For instance, in this case, does min and max of every frame, min and max of pixel values of every frame differ less than 0.1? Somehow trying to find constant frames, all white, all black, which sometimes is a defect, sometimes is a segmenter indication, and so forth. And then as a result, you get a list of intervals where that criteria holds. So from the Caminandes video, we see that there is a chunk of black frames at the beginning, something in the middle, something towards the end.
Right. So it's like finding positions or doing a select kind of thing, but on a video and on particular properties.
Right, right. And in fact, those intervals are exactly these intervals down here where we get close to 0. That's the same function, that roughly the same function. Here I used min intensity, here I'm differing min and max, but basically the same, same concept. So those are the 5 intervals that come back down here.
Cool. Yeah. I like that you've got those two together too, because that makes a lot of sense.
And just as an advisory to users, there has been some renames. The whole set of functionality is marked experimental for a reason. When we were designing our general processing analysis functions, we realized these names make more sense. So we ended up doing this one rename from video time series to video map time series. Same for track selection. We're going from video tracks, etc., to video track selection, etc. Just would be fair to mention that and highlight that. It is all going to be highlighted in our documentation, reflected there, so that the users will be able to hopefully easily adapt to the new syntax.
Right on. We are just about out of time, but why don't you take me through some of the image specific stuff just real quick?
Maybe the coolest thing that is coming, I think very useful, is a construct called animated image. We're not doing much as far as processing and analysis these guys in the system, but we are able to display them up there in the notebook. A lot of people have them. It's going to be great for, it's just like animated GIFs on the web. As useful as they are in that context, they're going to be useful now for us in our system.
Gotcha. Okay.
We have improved some of our face analysis capabilities. Most important feature is going to be face recognize. You have a data set of people labeled. You could have multiple examples for each class and then ask for who this person is, and the result could come back like so. Image scopes are a lot of people are used to seeing video scopes or vector scopes. Those are the names that people know these by. There's typically a grid of multiple plots, including image histograms, for instance, where people would like to do color grading or any other sort of color adjustment, image adjustments. These become very handy. So these are 2 new additions in the system, basically show the distribution of color in different spaces. And a lot of import-export. As I say, the connectivity has always been a major focus for us. For instance, HAIC files or HAIF files are becoming more and more popular. We've added support for importing the depth. And once you have the depth and an image, you can actually display them as, display the image on a surface that is elevated by the depth and so forth, or just do other things like refocusing and things that are these days very, very common using depth cameras. So,
cool.
Yep, that's about it for 12.2.
All right. Well, those were some really interesting examples. Thanks a lot. For anyone watching at home, if you haven't thought about using Wolfram technology for image and video processing, audio processing, it's a good time to get started. As you see, we've got plenty of improvements over the past year, lots of new functionality, and all sorts of new stuff coming up in the pipeline. So thanks again. This has been a lot of fun. Appreciate you joining me today.
Thank you for having me, Brian.
Thanks for joining us. You can check out other Wolfram Tech Talks, live coding streams, and more on the Wolfram Research YouTube channel, or see what else is new at wolfram.com.